Well, we're back again, and we're still deriving some equations for acceleration, velocity, time, and displacement. And this is going to be our fifth one of 5, at least for now, that we're going to derive. And I finally wised up and wrote the name of it beforehand, so you don't have to watch me write it. But this is going to be called velocity as a function of displacement. And to start off, we're going to write down a few things that we know to be true about average velocity. First of all, average velocity, v av, I can write it like that. It can be written a few different ways. We can write that as, oops, get that little dot thing out of there. We can write that as vi plus vf divided by 2. Again, and when you take the average of any two numbers, you add them together and divide by 2, and you have your average. But it's also true, I keep writing these little dots there. That out of there. It's also true that v average is our change in x, or our displacement, change in our displacement over our change in time. So what that means is we can set these two equal to each other. So delta x, change in displacement over change in time, is equal to v initial plus v final all over 2. Well, we have some things in the denominator here. We have this 2 here, and we have this t. So we're going to multiply both sides by t and both sides by 2. So the t will come up, as will the 2. They'll just cross over the equal sign on both sides. So it'll wind up being 2 delta x equals t times vi plus vf. And for our purposes right here, we're going to take this whole equation, or this whole part of the equation, vi plus vf, and drop it down below. We're going to actually divide both sides by that and bring it down here underneath the 2 times delta x. Because for right now, we're going to be wanting to solve for t. So t, or change in time, I should have written that here, delta t, is going to be equal to 2 delta x over the whole value vi plus vf. The reason we solve for t right here, and I'm going to make that in green, is because we're going to use that a little bit later. Let's put that on hold for now, and let's also recall that acceleration, I'm going to write it back up at the top here, acceleration is a change in velocity over the change in time. Oh my goodness, where did that come from? Acceleration is change in velocity over change in time, and so it can also be written as vf minus vi over change in time. And it can be written, if we bring our delta t up, that means that a times delta t is equal to vf minus vi. For our purposes, we're going to go one step further and take this vi and add it to both sides, so it will wind up over here on the left-hand side. So we're going to have an equation that has v final is equal to v initial velocity, plus a times delta t. Here is where that delta t from down below is going to come into play. This is going to come in and go right there. So we're going to substitute all of this, all that right in there for delta t in this equation. which means I'll move down here a little bit further. Our equation is now going to be Vf equals Vi plus A times all this, 2 times delta x over Vi plus Vf. Once again, let's now get rid of what's in the denominator here. And to do that, we need to multiply both sides by Vi plus Vf. So that means that's going to be multiplied over here. Why did that turn black? Oh, because I changed it to black. Let's just make it red for now. I'm going to multiply this. It's going to wind up over here, but it's also going to wind up, since this is added here, it's going to be wound up to be multiplied by that as well. So let's bring our Vi plus Vf up so that we have V final times Vi plus Vf equals V initial times Vi plus Vf. All that plus I'm going to say 2x, 2a times delta x, or 2 delta x, so x times a. Let's take now our Vf and our Vi and distribute these through the parentheses on both sides. So we have Vf Vi plus Vf squared equals Vi squared, stay with me here, plus Vi Vf, which is essentially the same thing as that right there, plus 2 delta x times a. Well, we're going to have our answer that's going to be solved for, we're going to be solving for Vf, or for Vf. So that's going to stay on one side of the equation, but it also means that some things are going to go away. For example, since Vf Vi and Vi Vf are added on both sides of the equation, they can just be canceled out. Which leaves us with a relatively simplified equation. A final answer, our equation being solving for Vf, is going to be Vf squared is equal to Vi squared plus, I'm going to rearrange this a little bit. I'm going to put the a before the delta x, but it doesn't really matter. It's all multiplied together. Plus 2a times delta x. That's our final equation 5, velocity as a function of displacement.